In this video, we'll explore computation and estimation. What I have here is how the categories are split up per grade level in the notion of computation and estimation. When we're starting off in kindergarten, we're modeling basic addition and subtraction. We continue to work with addition and subtraction, numbers getting larger throughout third grade, where we start to pick up some multiplication and basics of fractions. And then as we go through, we continue to add in all four operations of multiplication, division, addition, subtraction, looking also not only at whole numbers, but fractions as well. And we start to pick up our exponents and look at all order of operations together as we get into 5th, 6th, and 7th grade. When we get to 8th grade, we start looking at ratios, proportions, and then looking at radicals, both perfect squares and square roots. Now, when we think about trying to help students with computation estimation, the biggest place that they're going to need their help is going to be with fractions, especially the order of operations with fractions. So just a refresher for yourself, we're going to look at the four basic operations with fractions. With addition and subtraction, first thing we need to do is find a common denominator. We convert each fraction to its equivalent fraction with that denominator. Then we add or subtract our numerators. We keep the denominator and simplify. For example, if I had 3/5 plus 6/7, I can't add them as they are because I have unlike denominators. So I say, what would be a common denominator for 5 and 7? In this case, it'd be 35 because I could multiply 5 times 7. Now I ask myself, what do I multiply 5 by? I multiply it by 7, so I'm going to multiply the 3 by 7. And for the 6/7, I'm going to multiply both of them by 5. So now I have, instead of 3/5, I have 21 35ths. And instead of 6/7, I have 30 35ths. Now, since I have a common denominator, I can add my numerators and get 21 plus 30 is 51 over 35. Or I can change that to a mixed number and say it's 1 and 16 35ths. When I go to multiply fractions, I multiply my numerators and I multiply my denominators, then simplify my result. If I have a whole number, I'm going to put it over 1 so that I can look at the fractions together. For example, if I have 1/3 times 3/4, I'd look and multiply my numerators and multiply my denominators. 1 times 3, 3 times 4. That gives me 3/12. Now I'll look and say, can I simplify that? Well, I can divide both 3 and 12 by 3. And when I do that, I get 1/4. Now, why does this work? So let's look at what will make this work. Say I have two wholes. They're the exact same size. I'm going to do this to give you a visualization. I'm going to take my bottom one here, the tan rectangle, and split it into 3/7 vertically. So there's my 3/7. Now I'm going to take the blue one up here and split it into 4/5 horizontally. So I've got 4 shaded out of 5, 3 shaded out of 7. Now let's overlap them. So I'm going to drop down my 4/5 onto my 3/7. And if I look there, what I have is overlap. And that overlap represents 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes of the 35 total boxes in my image that I just created. And if I multiply 4/5 times 3/7, I will get 12 35ths. I just have to also remember to simplify. Now when I go about dividing fractions, often you'll teach students to invert and multiply or even keep, change, flip. And what I'm doing there is multiplying by the reciprocal. So if I have one fraction divided by, say, c over d, what I'm going to do is actually multiply by d over c. So 9/13 divided by 6/7, when I invert and multiply, that's going to become times 7/6. So then 9 times 7, 63, 13 times 6 is 78. I ask myself, can I simplify this? Yes. I'm going to divide both by 3 and end up at 21/26. Now, why does division work? If I recall just some basic facts of division, I know that for every division statement, there is a corresponding inverse multiplication statement. So when I have A divided by B, I know that B times that quotient will equal A. So if I look at it in fraction terms, I know that if I have one fraction being divided by another, I could write it as an inverse multiplication of the quotient times my divisor. So I got to think about, what would I have to multiply my divisor by to make this whole side become A over B? And that's the question that will make this work out. So if I look at that, I would have to multiply it so that I cancel the C and the D and still have the A and B. So AB times DC. And if I look, my D's would cancel, my C's would cancel, I'd be left with AB equals AB. So that's how I know that my inverse statement, or multiplying by the inverse, will be the same as saying the division of the two fractions.